Hey guys, and welcome to this video. In this video, we are going to be working on the analytical geometry section of the Senior Certificate May-June 2025 Paper 2 exam. So here's question 3. It says, in the diagram below, triangle SRT is drawn where R lies on the x-axis and S lies to the left of R. Okay, so there we go. We've got S over there. It has a Y value, but its X value is missing. T lies on the y-axis and the coordinates of S are m and 1. The equation of RT is 2x minus y plus 10 equals 0. So we need to make sure we put that down. Okay, and the first question, 3.1, says calculate the coordinates of R. Okay, so to find R, we need to see where exactly it is. So do you see that it lies on this line, which we already have the equation of, and it is specifically on the x-axis. So this is an x-intercept. And what do we know about x-intercepts? To find the x-intercept, or really at the x-intercept, the y value of this point is equal to 0. Okay, so since we already have the equation of that line, 2x minus y plus 10 is equal to 0, all we have to do here is make its y value 0. So this is now 2x minus 0 plus 10 equals 0. And so that gives us 2x, and we still have plus 10, but we can take it over to get negative 10. And then if you divide both hand sides by 2, x is finally equal to negative 5. So that means that the coordinates of R are negative 5 and 0. Okay, moving on to the next question. Okay, 3.2 says calculate the length of RT. Leave your answer in third form. Okay, so we just have to find RT. Now that we know this is negative 5, so negative 5, find RT. Do you see that T is on the y-axis, making this your y-intercept? And to find the y-intercept, what do we do? At the y-intercept, the x value is equal to 0. Okay, so all we have to do is make x equal to 0. Again, let's take the equation and make x equal to 0. Okay, so this is 2, and then in place of x, we say 0 minus y plus 10 is equal to 0. And then that gives us, as you can see, this y is going to be negative. You might as well take it over. So that's positive y is equal to 10. Okay, so that means we have the coordinates of t. Now, this is 0 and 10, and we can also fill that in here. So now that we have the coordinates of r and t, we can find its length using the distance formula. So let's put down the distance formula and our points r and t. Okay guys, remember that the formulas are in your formula sheet. So this means that RT is therefore, we'll say the square root of x2 minus x1. So you guys can just follow a specific order. So I'm going to say the top ones minus the bottom ones. So that's going to be x2 minus x1 is going to be negative 5 minus 0 all squared plus 0 minus 10 all squared. Okay, so these ones are not really difficult calculations. You can see that negative 5 minus 0 is negative 5. Negative 5 squared is 25. And then 0 minus 10 is negative 10. Negative 10 squared is 100. So we have the square root of 125, which you can put on your calculator. But because there's 25 in here, that's going to be 25 times 5, meaning square root 25 is 5. And then you have a root 5 left. Okay, so that is what RT is. It is 5 root 5. And moving on to the next question. The next question, 3.3, says, if it is also given that 2RT squared is equal to 5SR squared, calculate the value of M. Okay, so let's see these that they're speaking about, RT and SR. We already have RT, okay, so we just have to square that, which is just going to go back to, if you square that, it's just going to give you 125, okay, because this was already RT. Had you squared both sides, you'd have cancelled that root. So all we have to focus on is SR. Let's go ahead and find out what this is going to be. Okay, so let's look for SR. SR is going like that. Okay, so that's where the M comes from. So let's find the distance of SR using the distance formula. The coordinates S is M and 1, and then we know this is negative 5 and 0. Let's go ahead and do that first. Okay, so we are saying SR is equal to, and you don't really have to write your formula here. You can leave it as SR squared, is really not a problem. So instead of saying square root, I'm just going to start off by saying x2 minus x1. Okay, so the x2 minus x1, we can just take it as top and then bottom. So m minus -5, which gives you a plus 5, all squared, plus, and then y2 minus y1, which is 1 minus 0 all squared. Okay, so there we go. We can just do that. And so SR squared is equal to, you see that that's just going to become a 1. So let's go ahead and distribute this. You can, remember, write m plus 5 times m plus 5, but that takes really long. So what you can do is square the first term, which gives you m squared, square the last term, which gives you positive 25, and then first term times second term, or first times last, is 5m. Then you multiply this by 2, and that gives you positive 10m. Okay, so there it's expanded. And then you still have the plus 1 all squared here, which is just 1. Okay, so it means that SR squared is equal to m squared plus 10m plus 26. Okay, now let's go ahead and use the equation they asked for. So the equation is 2RT squared is equal to 5SR squared. Now we already know what RT squared is. RT squared, if you squared both hand sides here to get RT squared, you would just have 125. So it means that this is 2 times 125 is equal to 5 times all of that, which is m squared plus 10m plus 26. And now we just have to simplify this. Okay, if you multiply this by 2, it's going to give you 250. Okay, and then it's equal to, and let's distribute. It's not really necessary. You might as well just divide both hand sides by 5. Okay, so leave this like this, and then just divide both hand sides by 5. So divide by 5, divide by 5, and that gets rid of that 5 over there. 250 divided by 5 gives you 50 is equal to, and you have m squared plus 10m as a squared plus 26. And then we can take the 50 over. So we have m squared plus 10m plus 26 minus 50. 26 minus 50 is going to give us negative 24. So this is 0 is equal to, or we can just say m squared plus 10m minus 24 is equal to 0. And then we can factorize. Okay, so open up two brackets and then is equal to 0. Then m multiplied by m gives you m squared. And then we need factors of 24 that can give us a 10. But remember, one factor should be positive, the other should be negative. Okay, so 6 and 4 would not work in this case. If this was the only negative and that was positive, then 6 and 4 would work, but it wouldn't work here. So factors of 24, we can try 12 and 2. 12 times 2 is 24. But now if you make this one positive, positive 12 minus 2 gives you positive 10. But positive 12 times negative 2 gives you negative 24. So those are our factors. Therefore, m is either equal to negative 12 or m is equal to positive 2. Okay, so let's go ahead and look at where m is on the diagram, and then we can tell which one it is. So you see we have a positive and we have a negative one. So clearly m is the negative one. So negative 12, not the positive 2. Okay, so we'll cancel out. This is an option, and this is our answer for m. M is therefore equal to negative 12. Moving on to the next question. Okay, question 3.4 says, it is further given that V lies on ST such that VR is perpendicular to ST. Okay, so that's the main thing. VR is perpendicular to ST. And they want us to determine the equation of VR in the form of y equals mx plus c. Okay, so let's see. VR is perpendicular to ST. So you can see if these two are perpendicular, then they want us to find the equation of VR. Okay, makes sense. So we're going to use the whole idea of when two lines are perpendicular, what happens to their gradients? Okay, so it would mean that you see the gradient of VR multiplied by the gradient of st, when you multiply them, they give you -1. So to find the gradient of VR, you simply just say -1 divided by the gradient of st. So it's really just like this. Whatever the gradient of st is, right? Let's say st was 1/2. What it means about VR is simply multiply this by -1 and then switch the numerator and denominator. So it's going to be -2/1, which is just -2. Okay, that's just an example. So we don't always have to do this calculation. It's not really necessary, especially when you have numbers already. Okay, so to find the gradient of VR, we have to focus on the gradient of ST, which you can clearly see we have 2 points on ST. Okay, so let's go ahead and use that. We're going to use S, which is -12 and 1, and T, which is 0 and 10. Okay, so the gradient, first of all, of ST is, well, we're going to just have to write the formula since we don't really have it down before. So subtract like that. And then we can just say top minus bottom. So that's going to be 1 minus 10 over -12 minus 0. And so it means that the gradient of ST that's going to give you -9, and that gives you -12, which would be positive at the end. But you see that they have a common factor of 3. So divide this by 3, you get +3 over +4. Okay, so the gradient of ST is just equal to 3 over 4. So since you know they are perpendicular, then it would mean that the gradient of VR would be, remember, just multiply by negative and swap the numerator and denominator. So that's going to be -4/3. There we go. Okay, so we have the gradient of VR. Now that we have the gradient of VR, what else do we need to find its equation? Remember, the equation of a line is y equals mx plus c. We found the m part, so we need to find the c by using 1 point on that particular line. So since we're talking about this line VR, you see that we have the point -5. So we're going to use that. Okay, specifically -5 and 0. Okay, so we're going to substitute this point -5 and 0, the point R, and let's go. So you can use y equals mx plus c, or you could use this. Y minus y1 is equal to your gradient, which is -4/3, and then x minus x1. Okay, so this is going to serve as our x1 and our y1. So that is y minus 0 is equal to -4/3 times x minus -5, which gives you +5. Y minus 0 is just y is equal to, and we're going to distribute here. So -4/3x, and if you distribute that, you see numerator and numerator give you -20/3. There we go. So that is our answer. -4/3x minus 20/3. And moving on to the next question. Okay, the next question says, hence show that the coordinates of V are -8 and 4. So find V. Okay, so what do we know about that point V? Do you see that V is the point of intersection between this line ST and the line VR? We just got this equation. We already have the gradient here. So you can just find the full equation of this line ST first, and then use the fact that they intersect at this point. So we are going to make the equations equal. So equate the equations. Okay, let's go ahead and do that. So we just need to find ST first. So finding the equation of ST, we already have its gradient. Oh, we don't actually have to find it because you see that ST just has a very clear y-intercept. The equation of a straight line is y equals mx plus c. The c part is your y-intercept. So whatever your y-intercept is, you just put it there. We already have the gradient. So we have this equation. So we can just tell them that the equation of ST is y equals, and we have its gradient 3/4. So it's 3/4x plus 10. And we know the equation of VR is this. So we're just going to equate them. Okay, so we'll say y is equal to y, and we're going to say 3/4x plus 10 equals -4/3x minus 20 over 3. Okay, take that gradient over. That's going to be 3 over 4x plus 4 over 3x is equal to, and if you take the 10 over, it becomes negative, minus 20 over 3. And we just have to simplify here. 3 over 4 plus 4 over 3 is 25 over 12x is equal to, and if you say negative 10 minus 20 over 3, that gives us negative 50 over 3. Okay, so now to solve for x, you can either choose to divide both hand sides by this fraction, and then you get your answer, or you could just multiply by its multiplicative inverse, which is going to be 12 over 25. You see, that will cancel the 12 and that will cancel the 25. So this is an equation. So what you do on the one side, you must do on the other side. So therefore, x is equal to, and we're just going to, you can just find that on the calculator. That's perfectly fine. So multiply by 12 over 25, which gives us negative 8. Okay, just like they said the x value was going to be. Now that we have the x value, remember that it lies on both lines. If the x value is negative 8, you can just substitute that x value into either this line's equation or this line's equation, and you'll find the y value, since they are exactly the same at that point of intersection. So just take the easier one. I kind of like this one better because it just has positives and simple. So we'll take that and substitute it there. Okay, so y is equal to 3 over 4, and then in place of x, we'll say negative 8 and plus 10. Therefore, y is finally equal to, here we'll have these cancel. So the 4 will cancel and 4 there will cancel. You're left with negative 2. 3 times negative 2 is negative 6, and then plus 10. That's going to give you positive 4. Just like they told us. They told us the v should be negative 8 and positive 4. Therefore, v is indeed negative 8 and positive 4. Okay, moving on to the next question. Okay, the next question says R prime is a reflection of R about the line x equals to 0. Okay, calculate the area of RVTR prime. Let's go ahead and see what they're speaking about. Okay, so here is our diagram. You see, they say that R prime, the point that we're supposed to find first, is a reflection of R, right? R is negative 5 and 0. It's a reflection of R about the line x is equal to 0. So think about it. If we have x is equal to a number, and that's the equation of the line we have, is that going to be a vertical or a horizontal line? It's going to be a vertical line, because vertical lines, okay, you have to say x is equal to because they pass one particular number on the x-axis. They have different y values. See, y value over there, y value over there, but they have one particular x value, which is only that. So they start with x is equal to. Okay, so if this is the line x is equal to 0, then where does that lie? Do you see that at this y-axis, this is where we can draw a line that specifically passes the x value of 0 on this x-axis. Okay, so that is the line that we're referring to. So they're really just saying reflect this across the y-axis. That's really what that means. It is the y-axis. Reflect it across the y-axis. And when we do that, what will we get? So if this is negative 5 and 0, when you reflect it across the y-axis, you see it's just moving at the same distance from the origin to here. You see that that was exactly 5 units. Okay, so you would have moved 5 units to the left. So to get the reflection, you're going to move from the origin and 5 units to the right, which would end up at 5. So that is R prime. R prime is at positive 5, positive 5 and 0. Okay, and that one is negative 5 and 0. So if we have this, they want us to calculate the area of RVT R prime. So that is going to go like this: RVT R prime. So do you see the quad that it creates? This quad. So let's go ahead and draw that out first. Okay, so this quad, let's see how we can actually find the area. So firstly, do you see that this quad is made of triangles. Okay, so it has a triangle over here, one over here, and I already see something similar with these triangles. Remember that this is perpendicular. These two lines are perpendicular. Okay, we also know that the x-axis and the y-axis are perpendicular as well. So they're all right angle triangles that we have. We also can see that these two are sharing a length. Okay, so I'm just trying to see the similarities that we can see here. And there are also some lengths that we know. So let's just put down the lengths that we know. We know that at first they asked us to find, the first question was to find the length of, well, it's not the first question. The second question was to find the length of RT, which is 5 root 5. So we already have RT, which is 5 root 5. And we can see these lengths very easily. Okay, this is 5 units and that's 5 units. Okay, both of them are 5 units. Okay, what else can we see here? There's another length we can see. OT is exactly 10 units. Okay, because it goes from 0 to 10. So 10 units. So from that, you can see that these two triangles are congruent. Okay, so to find the areas of these triangles, it's quite simple because they're already right angle triangles. So we can just use the equation that area is equal to a half multiplied by your base multiplied by your height. Okay, so in all these triangles, we need their bases and heights. Here, we don't have the height or the base. So that's the only thing we need to do. Here we've got the base and the height, base and the height. Here we just need the base first, and then we also need the height, of course. Okay, so we just have to focus on these two. Let's go ahead and find VR and VT. We already have their coordinates. Okay, so VR, we're going to say square root of, so to find VR, x2 minus x1, which is negative 5 minus negative 8, which is negative 5 plus 8, all squared. And then plus, we have y2 minus y1, so top minus bottom again, 0 minus 4, all squared. Okay, so VR, let's just quickly find out what that is. Okay, so that's just going to be 3 squared and then 4 squared, 9 plus 16 is 25. So square root of 25 is 5. Okay, that's already looking good. If we know that this is 5, then VT, yeah, we can probably see that these three triangles are going to maybe be congruent. So let's just find VT quickly. We already have V here, just put T down. It's 0 and 10. So VT equals, and that's going to be y2, we just say top minus bottom, it's fine. So negative 8 minus 0 squared plus 4 minus 10, 4 minus 10 squared. Okay, that's going to be 8 squared, which is 64. 4 minus 10 is negative 6, so that's 36, and that's already 100. Okay, so VT equals the square root of 100, which is 10. So yeah, these three triangles are congruent. Okay, so I'm not really going to prove much. I'm just going to actually point out that 3 of these triangles are congruent. Okay, so we can just say that these triangles, and you can put them in their order that they are congruent. So for these ones, we can go this down to the perpendicular line and then to that. So this, we can call this TVR. So we can see that triangle TVR is congruent to triangle TOR. So TOR, which is also congruent to triangle TOR prime. So TOR prime. Okay, because all three triangles are congruent, okay, all their base and heights are exactly the same, so their areas are going to be equal. So when finding the area of this shape, it's made up of 3 triangles that are all congruent or all exactly the same. So just trying to see the name. What is the name of this shape again? Okay, RVTR prime. So the area of this shape, RVTR prime, is equal to 3 times the area of just one single triangle. We can say the triangle, the area of the triangle TVR. Okay, so this is 3 multiplied by, remember it's a half, times the base times the height. The base, you can see, is 5 and the perpendicular height is 10. So half times 5 times 10, and this will give us our answer. So half times 10 is already 5. 5 times 5 is 25. Times 3 is 75. So this is 75 units squared. There we go. That is the area of RVTR. Okay, and that is it for question 3. Moving on to question 4. Okay, question 4 says, in the diagram, M is the center of the circle, having equation this, okay? And then we have E, which is -1 and 3, and T are points on the circle. So they line on this circle's circumference. And then they tell us that EC is a tangent. Okay, very important. It's a tangent to the circle at E and cuts the x-axis at D. Then ED is 15 over 4 units. So we'll just keep that in mind. I can just underline it here so we'll remember. And then MT is produced, okay, to meet the tangent at C. Okay, and the first question is, write down the size of CEM. Okay, CEM, just, okay, you can already see what they're doing there. Let's just highlight this so we don't forget. ED is, yeah, that. So with CEM, do you see that this is the tangent, this is the circle, the tangent, okay, and the radius of that circle? They will always be perpendicular at the point of contact. So we can already see that the size of CEM with no reason needed is 90 degrees. Okay, this is Euclid. They didn't ask for reasons. They don't say with reasons. So that is that answer. Moving on to the next question. The next question, 4.2, says, determine the equation of the tangent EC in the form y equals mx plus c. Okay, so how do we find the equation of this tangent? Okay, you see that this is missing. So yeah, y equals mx plus c is not going to work in this case. But remember, this is a tangent. And you should always look at what did we work on? What did we prove in the previous question? We proved that this is 90 degrees. So these two lines are perpendicular. You see that you already have this point. So all you need is this point, and you'd be able to find the gradient of the radius. And we know it's perpendicular to the gradient of the tangent. So we can also find the gradient of the tangent. We can just use E as that point that lies on CE to find that y-intercept. Okay, so it's really just following the flow of the questions that they asked here. Okay, they've asked this type of question already here. Okay, where we just had to multiply the gradients to find that here. Okay, this question, they're just repeating that again. Okay, let's go ahead and work on this. So we have to find M first. We already have the equation of the circle, so we can easily find the center. If this is the equation of the circle, what it means is, okay, so remember that the equation of the circle looks like this. It says x minus a all squared plus y minus b all squared is equal to r squared, right? So if that is it, and you know that a and b are the coordinates of the center of the circle, then we need to see what a and b are here. So a is very clear to see. It's x minus 3, so we can see that a is 3. But what is b? Okay, if you ever have just y squared or x squared, it means that that center, right, its value was just 0, because you must have said y minus 0 all squared to just get y squared. Okay, so it means that this point is actually 3 and 0. So we know what m is. Okay, so using the equation, we know what m is. It's 3 and 0, so it's on the x-axis 3. So we can use this now to find the equation of EM, which is the radius. So let's do that. We're going to say the gradient is equal to, and you don't have to write the formula, it's fine, we already wrote it once. You don't get a mark for writing the formula, it's in the formula sheet. So this is y2 minus y1, so we'll say top minus bottom. The y value here is 0, so that's going to be 3 minus 0 all over, and we have -1 minus 3, so -1 minus 3. Okay, and that's going to give us, it's going to be a negative number, so that's going to be -3 over 4. So now, why does it look like it's the same thing? Okay, it actually looks a lot like this one as well. But okay, it's just negative 3 over 4 this time. Okay, so now, since we know this is the gradient of EM, that center of the circle, then we can use this to find the gradient of CE. So because they are perpendicular, therefore the gradient of CE is equal to, just multiply that by -1 and switch the numerator and the denominator. So that's going to be positive 4 over 3. Okay, we have its gradient now. So using y equals mx plus c, or the other equation, you just have to find c by substituting 1 point on that line EC, which is the point E. That's the only complete point we have there. So E is -1 and 0. And so we're just going to substitute E being -1 and 3, sorry, -1 and 3. Okay, let's just use y equals mx plus c here. So y equals, the gradient is 4 over 3x plus c, and then let's substitute that as our x and our y value. So that's going to be 3 is equal to 4 over 3, and in place of x, we're going to put in -1 plus c. So that's going to give you -4 over 3. Take that over, it's 3 plus 4 over 3 is equal to c. If you put that over 3, it's going to just be 9. So 9 plus 4 is 13. So that's going to be 13 over 3. Y equals 13. C equals 13 over 3. Okay, so that would therefore mean that the equation is y equals 4 over 3x plus 13 over 3. And that is the equation of line CE or EC. Okay, moving on to the next question. Okay, the next question is calculate the length of DM. Okay, so you know that we already have the equation of the tangent, and you see that D lies on this tangent, lies specifically on the x-axis. So it is an x-intercept, meaning at this point its y value is equal to 0. Okay, they've been very lenient with, honestly speaking, the May-June 2025 paper, they were very nice in my opinion, because 2024 was not like this. Okay, so to find D, use the x-intercept. So make y equal to 0. We'll take in that equation and we're just going to make y equal to 0. So in place of y, we say 0. And might as well just take this over, doesn't matter. -4 over 3x is equal to 13 over 3. And then to solve for x, you can divide both hand sides by -4 over 3 or multiply both hand sides by -3 over 4. Okay, and there we go. So the reciprocal is going to just get rid of that, -3 over 4. Therefore, x is equal to, well, 3's here would cancel. So you're left with a 13 over 4. Okay, and it's going to be negative. So it's -13 over 4. That is the x-intercept. That is what D is. D is -13 over 4 and 0. So to find DM, we know that M, the center is 3 and 0. Might as well just leave it like that. That's fine. And so let's go ahead and find that. This is a weird number, that -13 over 4. Okay, so let's find the distance. Now, you see, for this, you don't need a distance formula because it is a horizontal line. You don't need the distance formula for horizontal and vertical lines because their y values are just 0. It's not necessary. Okay, of course, for a horizontal line, the y values are 0. So you can just say the highest x value minus the lowest x value, and you will find the length of that line. So that's what we'll do here. 3 minus -13 over 4. That will give you DM. So DM is equal to 3 minus -13 over 4, which gives you plus 13 over 4. Okay, so if you put that over 4, so over 4 times 4 on the numerator and denominator, that's going to be 12 over 4. And 12 plus 13 is 25. So 25 over 4 would be your answer for DM, which we can write as a decimal as well. It's also fine. As a decimal, DM is therefore equal to 6.25 units. Okay, no rounding needed. So there we go. That is the length of DM like they asked us for. Okay, so that is the length of DM. Moving on to the next question. The next question says show that P equals -5. Where is P? Okay, you see the P lies on EC, which we already know the equation of. C is the point -7, which is the x value. This is the y value. So substitute these into that line. Okay, so let's go ahead and do that. So we need the equation of that line first. Okay, which is this, and let's substitute. So we know that C is this point -7 and P, which we're going to see this as our x and our y value. So let's just substitute. So the P is the y value, so we're saying that P is equal to 4/3, and in place of x, we say -7, then plus 13/3. Okay, let's simplify. So P is finally equal to, that's going to be, since they multiply the numerators, that's going to be -28/3, and then you're adding with 13. So what is 28 minus 3? And then it's just going to stay negative. Okay, which is 15/3. So it's going to be -15/3. -15 divided by 3 gives you -5. So there we go. And that is what they asked us to prove, that P was equal to -5, and it really is. Moving on to the next question. Okay, the next question says, calculate the coordinates of S if SEMC is a parallelogram and the x value of S is less than 0. Okay, let's see where SEMC is going to go. So okay, and the x value of S is negative, so it's going to lie here. Okay, so it means it could be somewhere like here, right? It's negative SEMC, and then we're just going to connect it. So S to E, and then MC, and then when you draw it together, it'll be a parallelogram. I'll just put it more, just so that we can actually draw a parallelogram, or I'll attempt to draw a parallelogram here and just call that point S. So this is S and SEMC. How do we prove that this is a parallelogram, given that S is somewhere there? Okay, let's see. Okay, so to prove that something is a parallelogram, to prove that a quad is a parallelogram, there are various ways, but you should always look for the way that best suits the shape that you have. See, if a shape is a parallelogram, another way to prove that it is one is to prove that the diagonals bisect, each other. So to prove that the diagonals bisect each other, here's how we do this. Okay, so here's what it means for them to bisect each other. You see, this line, let's say this one is shorter than that one, okay? Because your parallelogram, the diagonals won't really be the same. It's not a rectangle or a square. So if this diagonal is bisecting this one, it's just cutting it into two perfect parts. So let's say this is equal to this. And then if this diagonal is bisecting this shorter one, it's just cutting it as well into two equal parts. All this means is that they would meet at the same point, because you see now that you've just created a scenario of midpoint. You're saying that from here to here is exactly the same as from here to here. That makes this the midpoint. Okay, from C to D is exactly the same as from D to E. That makes this the midpoint. So all we're saying is they have a common midpoint. So this is one of the ways of proving that a shape is a parallelogram, to show that they have a common midpoint. So if they have a common midpoint, because this is a parallelogram, what we can do is find that midpoint first. Do you see that you already have C and E? We found what P was. That was -5. So just find that common midpoint first. And then when we have that midpoint, we will use it to find S. Okay, using the midpoint formula when you already have the midpoint. So let's go ahead and find the midpoint of CE first. Okay, so the midpoint of CE, which is that point D, but the formula for midpoint is x1 plus x2 over 2, and then y1 plus y2 over 2. And we know that that's the point D. So we can just say x1 and x2, that's just -7 minus 1, because it's plus -1, which is just -1 over 2. And then y's is going to be -5 plus 3 over 2. And let's just simplify. So D is finally, that will give you -8 over 2, which is -4. And that's going to be 3 minus 5 is -2 over 2, which is -1. So we know what D is now. Okay, so now that we have D, we can use D to find S. We now know that this point is -4 and -1. So we can use that to find S by saying this is the midpoint, and we're going to work with it as if we're trying to find the midpoint of SM. Okay, so in other words, really what we're just saying is that the midpoint of SM is exactly the same as the midpoint of CE. We already know the midpoint of CE is this point D. So we're going to use the coordinates of SM. S we don't have, it's X and Y. M we do have, it is the center of the circle, which was 3 and 0. Okay, so let's just put that down and find this. Okay, we might as well just do this on a new line. So we are saying here it's going to be x1 plus x2. x1 is x, and then plus x2, which is 3 over 2, and then y1 and y2, which is going to be y plus 0 over 2. And then we're saying that that midpoint is exactly the same as the midpoint of CE, which is -4 and -1. We already know that. So -4 and -1. So do you see that they both represent the point D, which is the midpoint of SM and the midpoint of CE. So that would mean that their X values should be exactly the same and their Y values should be exactly the same. So therefore, it means that X plus 3 over 2 is equal to -4, and might as well just call this Y because Y plus 0 is Y. So Y over 2 is equal to -1. And now we just have to solve for X and Y. Okay, so here you can multiply both hand sides by 2 to get rid of that 2 there. And so now that it's gone, it means that X plus 3 equals -8. And therefore X equals, if you take 3 over, it becomes negative, which is -11. Okay, and then here, simply multiply both hand sides by 2. And therefore Y equals -2. And there we have S now. S is the point -11 and -2. Okay, so that is what S is. We can just fill that in so we know we have it. -11 and -2. Okay, so that is it for that question. Moving on to the next question. Okay, question 4.6 says, if the radius of the circle centered at M is increased by 7 units, determine whether S lies inside or outside the new circle. Okay, support your answer with the necessary calculations. Okay, I just want to make sure that I do this as kind of like neatly as I can so that the calculations are not all over the place. They just follow a structure. So let's think this through. First of all, for you to prove that a point is inside or outside a circle, it would work like this. Okay, so we can just use the circle that we currently have right now. Okay, it's centered at M, which is 3 and 0. To find out whether a point lies inside or outside the circle, let us just keep this very simple. I'm just going to focus on points that lie on this x-axis, right? Let's say a point lies inside the circle. How would we prove this? Well, you see, for points that lie inside the circle, the distance from the center to the circumference, which is our radius, right? We would have to find that. So R is equal to, in this case, we don't have to overthink this. We already know what R is. That equation was x minus 3 all squared plus, and then equals 25. So remember that that stands for R squared. So your radius is 5. Okay, so you already know what that radius is. So here's the idea behind this. If R is equal to 5, right? And this point lies inside the circle, then you will notice that the distance from M to that point, that distance will be less than 5. That distance will be less than the radius. So we will know it lies inside the circle, okay? Because that length is shorter than the length of the radius. If it lies outside, then the distance would be greater than the radius. Then you know it lies outside. Okay, let's just keep that in mind as we go through this question. Okay, so they tell us that our radius is going to be increased by 7 units. So let's find that new radius. Okay, the new radius, because the old radius was just 5 units, but it's increased by 7 units. So the new radius is 12 units. Okay, and we need to find out, does S lie inside or outside? So we simply have to find the length of what? You need to find the length of SM. Okay, Find the distance from the center to S. Okay, because S does not change. The only thing that changes is that circle. Okay, it just gets bigger. If it looked like this before, because the radius increases, it just becomes bigger. Okay, so S is this point, -11 and -2. So let's find that. We already know what M is. It is 3 and 0. S is -11 and -2. Let's find the distance of this line. So we can say SM equals the square root of x2 minus x1, which is 3, minus -11, which is just plus 11, squared, plus 0 minus -2, which is plus 2, squared. Okay, so this is going to give us, and do you see that SM is equal to 10 square root 2, which is about 14 point. Okay, so SM equals 10 root 2. We know what that is as well. It's 14.14. And okay, let's use this and let's see. You see, you have to compare these two. So it's that scenario where I said that the distance, right, is greater than the radius. Okay, because you can see that's 14 point. We can also just say it's about 14.14, right? And because the distance is greater than the radius, that this means that it lies where? Okay, the distance between that is bigger than the radius, so it's outside. Okay, so you can actually just show them this. Show them that SM is greater than your new radius. You can call it R new. So therefore, it means that this point lies outside the circle. So S would lie outside of this new circle. And that is our answer. Okay, moving on to the next question. Okay, we're on 4.7, and 4.7 says, if ET is drawn, calculate the size of ETM. Okay, so we're going to need the diagram for this. So let's just get it down so we don't have to scroll up. Okay, so we see that there's this line ET that gets drawn. So from E to T, let's just make this a bright color so that we'll be able to just follow it. Okay, so we are joining from E to T, right? ET is drawn, and when that is drawn, they want us to calculate the size of angle ETM. So that's ETM, this angle over here. Okay, so let's look at that. How can we actually find this? Now, normally when you look at this, because this is analytical geometry, we're going to have to try to look at it from, that view. What can we actually find with this? We could try to extend some lines and maybe find some gradients. So the thing about this line is it's a little different, okay? Because you see we have this line over here, which we can easily find the gradient of. Maybe we even have the gradient of that. But we can easily find the gradient of that line. And then when you look at this angle, you're going to have to see how this was created. So you can start by drawing an imaginary x-axis. Remember, that's just going to be a horizontal line. And you're going to draw that horizontal line passing that middle, the point really, on where you can see that that angle was created. And to understand how this angle was created, you're going from this imaginary x-axis, and you will say that you'd have to find the angle of inclination of this line ET, and then find the angle of inclination of this line CM, which is not a problem. The only problem now is finding the angle of inclination of ET, because we know what E is, but we don't know what T is. So if we found T, we'd be able to find that angle of inclination. Okay, so that is one way to actually deal with this. Let's think about how we can find T. Okay, so with finding T, honestly speaking, I don't think I would want to go this route because it just looks like just a whole lot of work. To find T, the only way that it looks like we can actually find T would be like this. You see, we cannot for certain say that ET is a vertical line, okay? So we can't make any assumptions about that. We don't know. It's probably, maybe it's slanted, but we can't assume. So the only other way to find T would be to look at the line that is intersecting with the circle at T. So that will be CM. We'll have to take the equation of CM and equate it to the equation of the circle so we can find that point of intersection. Of course, it will give you two answers. It will give you the answer that would appear this side, because you see that if you extend CM, it's also going to intersect over there. So it's going to give you two X values, one that will be here and one that will be here. But you, of course, have to take this one and you'd be able to find it. Now, it's just a whole simultaneous equation thing. It's not that complicated. We can actually do that. And for the sake of understanding, I'll also look for other ways that we could have actually found the answer to this and just compare them to see, what kind of answers they give us, if it's going to be, decimals or parts or not, depending on the method that you use. So, okay, let's go ahead and start with that. I'll call that method 1. Let's start with this one. Okay, so method 1, angle of inclination, find t. So let's go ahead and do that. So to find t, you see that it intersects with the circle. So we'll take the equation of the circle, which is, we have the equation of the circle already. So we just take that equation and then we're going to equate it with the equation of CM, because that was the line that it passed. Okay, so this is the equation of the circle. And do we have CM? I don't actually think we have this. I don't remember actually finding the equation of CM. So this was the equation of CE or EC, right? We don't have the equation of CM. So we would have to find the gradient first and then find its equation. So you can see that it's -7 and -5, and then m is 3 and 0. So let's find that equation quickly. Okay, so first of all, we find the gradient of CM, which is y2 minus y1. So that's -5 minus 0 all over -7 minus 3. And this is going to give us, that's still -5. That will be -10. So that's -5 over -10, which is positive a half. Okay, so we know the gradient now. And now to find the equation, just use the easiest point, which would be 3 and 0. So we can say y minus y1, which would be, so we're using these two. So this would be x1. This is y1. So y minus 0 is equal to your gradient and then times x minus x1, which is currently 3. So 3. And that is just y equals a half x. And when that multiplies, it gives you -3 over 2. Okay, that looks good. So we've got the equation of the circle and the equation of line CM. And what we're doing here is we're equating it. But you see, with equating equations, it's like working with them as simultaneous equations. When you're working with simultaneous equations, the whole goal is to find out the points of intersection. So that's what we're doing here. So what I'm going to name this is equation 1, because it's the linear equation. And I'll call this one equation 2. Okay, so right now we already have y as a subject. So we can go ahead and substitute equation 1 into equation 2. Okay, so we still have x minus 3 all squared. That stays the same. Plus, and now in place of y, we put this in and then equals 25. So we're saying a half x minus 3 over 2 all squared is equal to 25. And then we just have to simplify here. So this will give us an x value. We stick with one x value. Here we square the x squared, square the -3, it's positive 9. And then they multiply and give you -3, but you times that by 2, which gives you -6x. Okay, so then here we're going to have to do the same thing. Square this. When you square it, it becomes 1 over 4x squared. And then when you square that, it becomes 9 over 4. And then when you multiply both of them, you see a half times -3 over 2 gives you -3 over 4. But then you must multiply this by 2. Of course, it's going to be -3 over 4x, and then multiply by 2. You see, if you multiply by 2 across, 2 will cancel. So 2 cancels here, 2 cancels here, leaving you with 2 left, meaning your answer is just -3 over 2x. Okay, so there we go. And it's equal to 25. Okay, let's just simplify. If you have this and that add together, x squared plus 1 over 4x is like saying 1 plus 1 over 4, because that's 1x squared, which is going to be, you just say 1 times 4, which is 4 plus 1 is 5. So that's 5 over, and the denominator stays exactly the same, x squared. Okay. And now these with the x's. So that's a negative 6 minus 3 over 2. Negative 6 times 2 is negative 12. You might as well just look at it as if they were positive. Like it's 6 and 3 over 2. Okay, so 6 times 2 is 12, plus 3 is 15. So that's 15 over 2. So that is going to give you a negative 15 over 2x. And don't mind the denominators. We can actually get rid of that. It's not a problem. Then we have 9 plus 9 over 4, which is the same thing as 9 over 4. 9 times 4, we have 36, and then plus 9, which was going to give you 45. Okay, so that's going to be 45 over 4, and then we'll just put that there. Okay, so that's positive 45 over 4. And that's what we have there. Okay, so you see the x squareds are done, the x's are done, the constants are done, except for that 25, of course. So the 25 can come over now, that's fine. Minus 25 is equal to 0, and then we can just work on that. So that's going to be 5 over 4x squared minus 15 over 2x. And then to subtract these two. So you can just rewrite 25 with a denominator of 4. So if you rewrite that with a denominator of 4, then you must multiply this by 4 as well. You know that 4 times 25 is 100. So that's going to give you, that's 45 minus 100 over 4. Okay, so 100 minus 45 is 55 already. So that's going to be negative 55 over 4 is equal to 0. That's what we have there. Okay, so it's not a problem that we have denominators because we can actually get rid of those. Okay, so you can look at what the biggest denominator is, which you can see throughout it's 4. So we can just multiply both hand sides by 4 to get rid of that. But apart from that, do you see that on the numerator, you have a common factor of 5 all through? Here's why I'm getting rid of it now. If I just multiply both sides by 4, yay, the 4s will leave, okay? They'll all leave wherever they are. But then the 5s are still going to be on the numerators, okay? What I mean by that is there will still be a common factor of 5 on each numerator, even if this one is over 2. So yes, a 2 here will cancel and a 2 here will cancel. But this 2 will multiply with this 15, giving you 30. There's still a common factor of 5. So what you can do to just get rid of that already is just to multiply this by the common factor on the numerator, which is a 5 that we can see all through. And the denominator that needs to leave is a 4. So you need that denominator to be on top, on the numerator here. And you need this common factor to be on the denominator. That way it's going to get rid of all of these things. And what you do on that side, you must do on this side. So I'm going to multiply by 4 over 5 as well. And look at what happens. You see here, what's going to happen is you have 4 over 5 times 5 over 4. They will cancel diagonally. So they're gone now. And all you have here is x squared, which is what we want. And then when you multiply here, if you say 4 over 5, multiply by 15 over 2, look what happens. 5 and 5 cancel here. But here, 15 divided by 5 is 3. So you have 3 left here. Here, 2 and 2 would cancel. But 4 divided by 2 is still 2. So now you have a 2 times 3, which is 6. And now you have here minus 6x, okay? And then here, if you say 4 over 5 multiplied by, we know it's negative, but we'll just keep it positive so long. So here when we cancel, 5 divided by 5 is still just 1. 55 divided by 5 is 11. And then here your 4 and 4 cancel. So you're just left with the 11. So it's negative 11, okay? And then it's equal to 0. Okay, so you see we have a trinomial. We can just factorize that. So open our brackets is equal to 0, and we have x and x. 11 is a prime number, so there's no way it's going to give you anything. You can't actually factorize this. You're going to have to use the quadratic formula. So let's put down the quadratic formula. Okay, so as you can see here, our a value is 1, our b value is negative 6, and our c value is negative 11. Okay, and when we substitute, you see what we get. Now, on your calculator, the order is just going to be a little different. It's going to say 3 minus 2 square root 5. Okay, so this is when we substitute the negative. So let's substitute the positive. And then the second solution is x equals 3 plus 2 square root 5. Okay, and it's better to leave it in third form. Well, of course, we're going to be still looking at that just so that we can see the value. So you see, this one is the positive one, and then the other one is the negative one. Okay, so negative 1.47. When you look at your diagram to see where these x values are going to be, remember, it's this line CM, if it was extended, because it's supposed to naturally be extended on the Cartesian plane, and it's going to intersect here and here. You see that this is the one with the positive x value. This is the one with the negative x value. So we need to take that negative one, okay? So our answer is not going to be that 7. It's going to be that negative one. So we cancel this one here, and we're going to take this one. Okay, so this is our value for t. This is the x value of t, okay? And now that we have this, we can find its y value because we need both so that we can find the gradient. This method seems really long, but I'm just going to try to see the methods that we can actually use to solve this, just so we can compare the answers. Okay, so now we just need that y value. And remember, the whole point of finding this point is so we can find the gradient of that line and then use the angles of inclination to end up finding ETM. Okay, so since this is the x value, all you have to do is take this, because this is like your equation number 3, and you're going to substitute equation number 3, x is equal to something, into this equation, y is equal to this, because it's a simpler equation to use. So we'll take this equation and let's substitute that into it. I'm not going to put it in decimal form because that is going to tamper with the answers. Even if it's just to the last decimal, it's going to tamper with it. I'm trying to get the exact answer. So we say y equals 1 over 2, and then in place of x we say 3 minus 2 square root 5, and then minus 3 over 2. Okay, so y is finally equal to, I'll just put this on the calculator to just get the answer quickly. Okay, so I used the ans button because it had that answer recorded, and this is negative square root of 5. Okay, so we know what t is now. T is really just the points with the x value, 3 minus 2 square root 5, and then the y value is negative square root 5. Okay, so we know what t is now. And now we can use this to find the gradient of ET. So remember that E is negative 1 and 3, and we know what t is now. So the gradient of gradient ET is equal to y2 minus y1. We can start with that as the y value. So negative square root 5 minus 3 all over, and then x2 minus x1. So that minus negative 1, which is going to become plus 1, minus minus. Okay, so let's find the gradient of ET. Okay, so this is what it gives us, but of course on the Casio calculator it's just going to be, you can see the denominator, they're both 2, so it's really just going to be we can start with the 11 since it's the whole number there. So 11 on the numerator, of course, 5 square root 5 all over 2. Weird looking gradient, but okay, if we use the gradient like that, then we can actually find that. Remember, when we deal with the other methods, we're not going to find whatever we already have. You would just have to follow the same procedure to find that, and then we will be able to just use whatever other method. Okay, so this is the gradient. Here is how we would find this angle. Okay, just as I've explained here, what's going on is you're using the angle of inclination by sketching down an invisible x-axis. Okay, so this is an x-axis, and you're going to find the angle of inclination measuring from the x-axis all the way to that purple line ET. And then when you find that angle, you see it's this big. You're going to say that angle minus this little angle here, which is the angle of inclination of CM, which we also have. Okay, so we can actually put that in a nutshell. What we're doing is take the angle of inclination of the bigger one, which is ET, that big angle, minus the angle of inclination of CM. Okay, so ETM is equal to, and we're going to put that down. Okay, so now we can just look separately at how to find these angles. You see, you're just going to have to check whether this is a positive or a negative value or not. That is going to be very important. With ET, is that going to be a positive or a negative angle? When looking at the gradient, look at the decimal form. Do you see that that's a positive number? It's positive 11 point something. So you don't have to account for the fact that it's going to give you a negative. If the gradient was negative, then you would have to still add 180 degrees depending on which angle you're trying to look for. Okay, so we're only measuring from the x-axis all the way to here. So we are moving anti-clockwise. That's the normal way of measuring angles, and that's perfectly fine. So to find that gradient, you simply say tan of theta, of course, of ET is equal to that gradient 11 points, but of course it's going to be in third form. And then you're going to take tan over, or use the second function of tan on both sides. So that's the angle of inclination of ET being equal to shift tan of that. And then we'll put that down. Okay, so you see that that's perfectly fine. We don't have to use any 180 degrees on that. Now for CM as well, as you can see, this is an increasing function. Its gradient was also positive. We found out that the gradient of that was a half. We already found it. See, of CM, it was a half. So that was perfectly fine. We can also say tan of theta of CM equals a half, and then shift tan of a half. That's perfectly fine. Okay, so why am I doing that there? So we don't have to find it separately here. We'll simply say ETM is equal to the angle of inclination of ET. That will be shift tan, second function of tan, and then the gradient, which we know is all of this over here. Okay, so we're not going to change that. We're going to try to keep it the same so it will not be a problem or round off where it shouldn't. Okay, and then minus, and we're saying the angle of inclination of CM. The angle of inclination there, the gradient was a half, so that's going to be minus shift tan of a half. Okay, now that will give us that angle ETM. Let's go ahead and find that. And there we go. We get 58.28 degrees. Okay, so that is that. Now remember, guys, we're still going to deal with the second method, because I do see another method that we can use here. So if we were not using the angle of inclination, we could have also used this method. So this is not... we could also use Euclidean geometry. Okay, so the first method that we are using is a method or a topic that we work with in analytical geometry, which is angle of inclination. Okay, the second method we're going to use is a topic that we use in Euclidean geometry. And here's how it works. Do you see that this shape is part of a triangle? It's part of this little triangle over here. And this triangle has some special properties. Do you notice that from here, from M to E, that's a radius, and from M to T, that's also a radius. So you have an isosceles triangle here because these two are equal. So that would mean that the angles opposite these equal sides are also equal, meaning this angle is equal to this angle. Okay, so here in this one, the only thing you would have to focus on finding is, it depends on how you look at it. You could focus on finding the center angle here, and it will help you to find these two angles, which ultimately, of course, helps you to find ETM. Okay, so let's go ahead and use Euclidean geometry here. Okay, so method 2, isosceles triangle, Euclidean geometry. Okay, guys, also just note that if you guys are satisfied with the first answer already, you can already stop watching the video from here. I'm just trying to show extra methods of working through this question, okay, as we see. Okay, now, since these two are already equal, you can already state that, and let's focus on how we would be able to find this angle over here. It's weird how I say this is Euclidean geometry, but we're still using analytical geometry. Just in this situation, to find this angle, because of how it is structured, you would be able to find it like this. So you could use the angle of inclination again. So we're looking at this as the x-axis, and we're going to find the angle of inclination moving clockwise, like that, okay, of that little part over there. And then we'll find of this little part over here, and then together they make up the center angle, angle EMT. Okay, so that's what we could do as well. Now I'll just check through the question if we have EM, the gradient of EM, and we already have the gradient of CM, okay, or MT, because it's CM. We already have that. So remember, I'm not going to find it again. You would have just used that same method to find it. So let's check. Do we have the gradient of EM? Okay, and we already had the gradient of EM. You see, we needed it to find EC, to find the equation of EC, because those two lines were perpendicular. So the gradient of EM is negative 3 over 4, and we're going to just use that. Okay, so let's find the gradient of EM. Okay, so let's put down the gradient of EM. We're saying the gradient of EM is equal to negative 3 over 4. And we already know the gradient of ET. And we already know the gradient of TM or CM, which we already found here. Of course, remember I said I'm not going to just find it again. We already have that gradient. CM is the exact same gradient as TM. Since they are collinear, they're on the same line. Okay, so that gradient was a half. We already have that. So now if we put that down, that is going to be very helpful. So the gradient here is a half. We're going to focus on finding their angles of inclination. So with angle of inclination, you need to always just be careful and look at which angle you are referring to. With EM, we know the gradient of EM is negative 3 over 4. Okay, so let's keep that, negative 3 over 4. If you were finding the angle of inclination, you would say shift tan of negative 3 over 4. But here's the thing. You need to make sure to find that first, because do you see that this line EM is decreasing? When you read it from left moving to right, it's decreasing. This guy would walk down this line. It's decreasing. So the angle of inclination that we're trying to refer to here is this one that is going to show us a negative number over here. If you say shift tan of negative 3 over 4, do you see that you get a negative answer? Okay, which is what we're looking for. We're looking for this. This is the one that is being measured clockwise instead of the correct way of measuring angles, which is anti-clockwise. Okay, so that's actually what we're looking for. But you're just going to, of course, have to make it positive. So you can multiply it by negative 1. It's fine because we're still referring to the absolute value of the angle. The angle is a size. It doesn't have to be negative. Okay, so you see how that one is 36.869. Okay, and then this one, to find this one, this is an increasing function. You're not going to have a problem with that. You would just say shift tan of 1 over 2, which is just 26 point that. So 26 point that. And we can just go ahead and work on this. So add these two angles together to get EMT, and then say the angles in a triangle add up to 180 degrees. Since these two are exactly the same, we'd be able to find it. Okay, so I'm just writing what the center angle is made up of. It's the angle of inclination of EM plus the angle of inclination of MT. And then this is going to be those two added together. So EM was the 36 points, but we don't have to say that. You can just say shift tan of negative 3 over 4, or just say positive 3 over 4. So it gives you the positive 1 instead of multiplying it by negative 1. And then add it to shift tan of 1 over 2. Okay, and then that will give you your answer. So we're adding this to shift tan 1 over 2, and you see that I multiplied. So these should be added together, and then look what they give you, right? They still give you this number 63.434. I'm not going to round off yet. So when we're adding those angles together, everything in that triangle, you know that these two are exactly the same. So instead of calling this one TEM, I'm just going to call it ETM as well, since they're exactly the same. So I'm saying angle ETM plus angle ETM plus angle EMT, that they add up, and because they're in a triangle, they give you 180 degrees. Okay, so we can just put that down. So we will end up having 2 ETM plus EMT, which is this number 63.434, and they give us 180 degrees. And then you'll say 2 ETM is equal to, and then it's going to be 180 minus 63.434. See, I didn't round off yet because I still need to divide by 2. Okay, so it's this answer, and then you're going to say 180 minus that number, which gives you 116. Okay, so ETM, and then it gives you 116.565, which I'm not rounding off yet. Then finally, we divide both hand sides by 2, and your answer for ETM is finally going to be, so is equal to, and then just divide the answer by 2. Okay, and then the answer again is 58.28 degrees. Okay, so there we go. We were still able to get the same answer. Now there's a third way of putting this in, and why not just put it in? This is going to be a video that's going to be up for a while, so might as well just put it in. The third method, method 3, we could actually use trigonometry. So this is using the lengths of lines. Okay, lengths of lines, and this is a topic that we're going to, well, it's actually using the cos rule. Not really length of line, yes, but using the cos rule, and this is a topic in trigonometry. Okay, so let's go ahead and use that. Remember, anything we've already found, I'm not going to find again. You already have the steps to find that. So if we didn't use this method, we could have actually used trigonometry to find this. You see, looking at this triangle here that we're focusing on, all you would need to do to use trigonometry to find that angle, okay, is if we were looking for this angle and we don't have any other angle, we already know, well, with trigonometry, there's actually more than one way that you could have actually done this, but it's fine. You could have already known that the radius of each of these, because remember that the radius, okay, or r squared was 25. So it means that r is just 5. So the radius here is 5, and that's 5. You would use this, and you would also need ET. Okay, so you would have to find ET, but at least you don't have to find this angle. So we can actually just quickly find ET using these coordinates. Okay, we can just quickly do that. I'll just put it down here, which would be this. Okay, so it's that square root, and then you have 10 bracket negative square root 5 plus 5. Okay, so all of this. So you see that if we have this side now, that we can actually use the cosine rule. Okay, so you see the answer is actually exactly the same. So ETM is still equal to 58.28 degrees. Okay, it's just a longer road to actually get that answer. Okay, it looks short here because we already found the other things that we needed, like T already, and the length, we just needed the length here. Okay, so you can, but remember, it's best to always use simpler approaches because you'll make less mistakes. Okay, you run into less mistakes. So honestly speaking, the approach that I would actually go with is this one, the Euclidean geometry one, because it's much simpler. Sure, you still have to find that gradient, okay, but it's fine. It's not that bad. With this one, I wouldn't actually go with this too much, because if you make a mistake in the simultaneous equation, then, you know, your answer is not going to look like the answer. You will, of course, still get answers for your steps, but you see, you won't arrive at that answer. Okay, so that is it for the analytical geometry session. Sorry for making it this long. I just wanted to show you the 3 ways, and there are probably more ways to even find that. So that is the end of this video, and I will see you guys in trigonometry.